Hello y'all, Professor Marianne Barber here. This lesson is called Inequalities. Some mathematical problems have solution sets as opposed to just a particular solution or two. Solution sets typically involve inequalities and can be expressed using set notation, a number line, or the more common and standard interval notation. Upon successful completion of this lesson, you will 1. Be able to solve linear inequalities. 2. Be able to solve nonlinear inequalities. 3. Be able to solve absolute value inequalities. And 4. Be able to model with inequalities. Rules for inequalities. Rules 1 and 2 are the addition and subtraction properties. Adding or subtracting the same quantity to both sides does not change the direction of the inequality. Rules 3 and 4 is for multiplication of inequalities. If the same positive number is multiplied to both sides, the direction of the inequality remains the same. If the number multiplied to both sides is negative, then the direction changes. Rule 5 is the reciprocal property. Taking the reciprocal of an inequality reverses the direction of the inequality. Rule 6 allows for the addition of inequalities. And finally, Rule 7 is the transitive property, which states that if A is equal to or less than B, and B is equal to or less than C, then A is equal to or less than C. Solve the inequalities. A. 4x is less than 10x plus 5. Let's begin this by subtracting 10x from both sides of the inequality. 4x minus 10x is negative 6x, and that will be less than the quantity 5. We have to divide by a negative number to isolate the variable. When you divide or multiply by a negative, you must switch the direction of the inequality. So, dividing by negative 6, x is greater than negative 5, 6. This answer expressed using set builder notation is bracket x, such that x is greater than negative 5, 6. And the answer expressed using interval notation is open parenthesis because it is not an included value. Negative 5, 6 going on indefinitely means infinity, and then parenthesis. B. 5 is equal to or less than the quantity 3x minus 4 is less than 14. In this compound inequality, the goal is still the same, that is, isolate the variable. To begin, we will add 4 to all three parts. Leftmost, 5 minus 4. 5 plus 4 is 9. Is equal to or less than, the term that remains in the middle portion is 3x, and then adding 4 to 14 will give us less than 18. Now we divide by 3 in all three parts to get the x by itself, so you have 9 divided by 3, 3x divided by 3, and 18 divided by 3. 9 divided by 3 simplifies to 3. The middle term, 3x over 3, is x, and 18 thirds is 6. The answer expressed in set builder notation is x such that 3 is equal to or less than x is less than 6, and then close brackets, and in interval notation, use the bracket to indicate that the 3 is included, so bracket 3, comma 6. It is a strict inequality, so open parenthesis. C. X squared plus 2x is equal to or less than 8. To solve this inequality, as you would in an equation, it must be set to 0. So we'll write this as x squared plus 2x, and then subtracting 8 from both sides of the inequality, minus 8 is equal to or less than 0. The quadratic x squared plus 2x minus 8 factors into a product of two binomials. The binomials are x plus 4 times x minus 2. This is still equal to or less than 8. When setting each of these factors equal to 0, you see that at x equals negative 4 and again at x equals 2, the quadratic x squared plus 2x minus 8 is going to be equal to 0. That can split the number line into three different regions where something critical happens. At negative 4, the inequality equals 0, and again at 2, the inequality equals 0. We're going to use this fact to create a product of number lines to determine the sign of this entire inequality. The sign, the SIGN, tells us whether or not the expression's less than 0 or greater than 0. We have two linear factors, x plus 4 and x minus 2. Let's begin with x plus 4. With x plus 4, we know that at x equals negative 4, that term is equal to 0. Let's select a number a little bit bigger than the negative 4, like a negative 3. Negative 3 plus 4 is a positive number. So we'll put in 3 plus 4. Everything to the right will be positive. Now let's select a number less than negative 4, like negative 5. Negative 5 plus 4 is negative 1, so the sign is negative. Let's continue with this process for the factor x minus 2. At x minus 2, we know that for the number 2, 2 minus 2 gives us a 0. Let's select a number slightly bigger than 2, like 3. 3 minus 2 is a positive number. And pick a number slightly less than 2, like 1 or even 0. We see that numbers to the left, 2 in this linear expression, is negative. Now, let's multiply the signs together. That is, we're going to look for the sign of the product for x plus 4 and x minus 2. Critical things happen at negative 4 and again at 2. Let's multiply the signs. Negative times negative, the product is positive. Positive times negative, the product is negative. And positive times positive, product is positive. In the inequality x squared plus 2x minus 8, we want equal to or less than 0, which means negative. That's the middle interval, starting at negative 4 and ending at 2. So the answer in set builder notation would be bracket x, such that negative 4 is equal to or less than x is equal to or less than 2. And in interval notation, you use the bracket to indicate that the endpoint is included. So negative 4, a bracket, then negative 4, comma, 2, then bracket. X times x plus 3 quantity squared times x minus 5 is greater than 0. The factors x, x plus 3 quantity squared, and x minus 5 are zeros when x equals 0, x equals negative 3, and x equals 5, respectively. These values partition the number line into 4 intervals. The intervals are from negative infinity to negative 3, from negative 3 to 0, from 0 to 5, and 5 to positive infinity. Let's denote the signs of each factor on the number line. The factor x is 0 at 0. It is negative to the left of 0 and positive to the right. The factor x plus 3 quantity squared is 0 at negative 3. The linear factor x plus 3 is negative to any number left of negative 3. But when squared, it is positive. To the right of negative 3, it is positive, squared or not. The factor x minus 5 is 0 at 5. It is positive to the right of 5 and negative to the left of 5. In the diagram, multiply the signs within each interval. And the interval from negative infinity to negative 3, we have negative times positive times negative. The product of negative, positive, and negative is positive. In the interval from negative 3 to 0, we have negative, positive, and negative. Negative times positive times negative, the product is positive. The next interval, 0 to 5, we have positive, positive, and negative. The product is then negative. And the rightmost interval, from 5 to infinity, the positives are for all three factors, so the product is positive. The inequality is for greater than 0. The number line diagram shows that the inequality is satisfied in the intervals negative infinity to negative 3, union negative 3 to 0, union 5 to infinity. We do not include the negative 3 because the inequality is a strictly greater. Solve the inequality 5x plus 1 quantity divided by x minus 2 quantity is equal to or less than 3. To begin this problem, we'll take the 5x plus 1 over x minus 2 and subtract 3. So that expression will be equal to or less than 0. In order to add or subtract fractions, we need a common denominator. We'll get that. Let's go ahead and write the first term again, 5x plus 1 divided by x minus 2 minus 3 times, and the factor of 1 will multiply will be the denominator of the first term, x minus 2, divided by x minus 2. That's still equal to or less than 0. We'll distribute the 3 to the second term. So the 5x plus 1 divided by x minus 2 minus, we only multiply it through the numerator, so 3x minus 6 divided by x minus 2 is equal to or less than 0. Let's write this all over one common denominator expression. So the denominator will have x minus 2. This is equal to or less than 0. The numerator, 5x plus 1. Distribute the negative, so minus 3x, and then negative times negative would make it a positive 6. We can combine some terms in the numerator. 5x minus 3x is 2x. 1 plus 6 is 7, and the denominator is still x minus 2. That is equal to or less than 0. Now we have an expression that we can put on a sign chart diagram to determine the solution intervals for which it's going to be equal to or less than 0. The numerator, 2x plus 7 equals 0 when x is equal to, solving for x, negative 7/2. And the denominator, x minus 2 equals 0, solving for x, when x equals 2. These two numbers let us divide the number line into 3 separate intervals. The interval is from negative infinity to negative 7/2, negative 7/2 to 2, and then 2 to positive infinity. Let's begin the sign chart work with the x minus 2. Now at x minus 2, the denominator equals 0. Since the denominator cannot be 0, we'll use an open hole to indicate that that value is not included. Select a number greater than 2, or to the right of 2 like 3. 3 minus 2 is a positive number, So we know that the number line will remain positive to the right of 2. Then because it's a line to the left, that factor is negative. Let's look at the numerator term, 2x plus 7. 2x plus 7 equals 0 at negative 7/2. Now, to the right of a negative number such as 0, you're going to have 2 times 0 plus 7, that's positive. And if we pick a number to the left, say like negative 5, negative 2 times 5 is negative 10. Negative 10 plus 3 is negative. Now we are in a position to look at what happens with the quotient 2x plus 7 divided by x minus 2. We'll mark those critical values, solid for the negative 7/2 and an open for the positive 2. Multiplying two negatives together in the leftmost region, negative times negative is positive. In the middle region between negative 7/2 and 2, we multiply a negative and a positive, and that product will be negative. And finally, in the rightmost region, the product of two positives is positive. Now, we are looking for the interval in which the answer is equal to or less than 0. Normally, you would use brackets on both ends. However, the denominator is not defined, so in expressing this answer, you would have bracket negative 7/2. You can have a 0 on the numerator, but on the right interval end, we have two open parentheses because you cannot have a 0 in the denominator. 2. Properties of absolute value inequalities. For the inequality, the absolute value of x is less than c, we can write this in equivalent set notation as negative c is less than x is less than c. On a number line graph, we would denote the negative c with an open hole and a positive c with the open hole and connect the line in between. For the absolute value inequality, absolute value of x is equal to or less than c. The set equivalent notation would be negative c is equal to or less than x is equal to or less than c. The number line would have solid circles for the negative c's and a line in between. The solid circles mean that the value is included. The open circle means that the value is not included. For the inequality, the absolute value of x is greater than c. The equivalent set notation is negative c is greater than x or c is less than x. In number line notation, you would see that there is a gap in the middle, an open hole at negative c and the line going to the left, an open hole at positive c and the line extending to the right. And for the absolute value of x is equal to or greater than c, the equivalent set notation is negative c is equal to or greater than x, or c is equal to or less than x. Again, the number line is split. At negative c, there is a solid dot, and the line extends to the left. At positive c, there is also a solid dot, and the line extends to the right. Solve the following absolute value inequality. The absolute value of 5x plus 7 is greater than 22. When the greater side faces the absolute value, that tells us we have two separate inequalities. They would be either less than negative 22 or greater than positive 22. So the expression is 5x plus 7 is less than negative 22, or 5x plus 7 is greater than positive 22. Now we'll solve each of these inequalities separately. Subtract 7 from each side, so 5x is less than negative 22 minus 7 would be negative 29. Then we divide by a positive number, so dividing by 5, you get x is less than negative 29/5. Or is denoted by the union symbol. Continuing to the second part, we subtract 7 from both sides again. So you got 5x is greater than 22 minus 7 is 15. Divide by 5 on both sides. You get x by itself, so x is greater than 3. To express this answer using interval notation, we would write negative infinity, comma, negative 29/5, close it with a parenthesis, union, and then on this one we would start with 3, comma, then positive infinity. Solve the absolute value inequality. The absolute value of the quantity x minus 3 is equal to or less than 1. The properties of absolute value inequality tells us that we write this expression as a compound inequality with negative 1 is equal to or less than x minus 3 is equal to or less than 1. The goal is to isolate the x, so we will add 3 to all three parts of this inequality. From the leftmost, negative 1 plus 3 is positive 2 is equal to or less than negative 3 plus 3 gets rid of the constant, so x by itself is equal to or less than 1 plus 3 is 4. This answer expressed in interval notation is bracket because the 2 is included, so bracket 2, comma 4, and again bracket for the 4.